Hey guys, okay, so this video is about figuring out how much time it's going to take to vaporize or melt something. Basically what you're going to know when you come into this problem is you're going to know the formulas that I gave you in my first video, which is called the Improved Heating Curve Tutorial. If you don't know those formulas, refer back to that. I'm not going to go over them again to save you time for those of you who've been keeping up. They can also be found in your textbook or in Dr. Yang's slides. Or Dr. Naughton-Belt's, I'm sure. Anyway, so to find the duration of a phase change, and duration is just a fancy word for how much time it takes, and you can use this for either when we're vaporizing something or melting something, because that all happens at the same temperature. We're not using the heat equals MCAT formula. So, what we'll be given when we come into this is we'll be given some enthalpy of either vaporization or fusing. So it'll say delta H VAP or delta H FUS. Same difference. It'll do the same thing. So you'll be given some number of kilojoules per mole or joules per mole. I expect you guys to know how to convert between those two, and if you don't know how, you can look up the SI units of conversion to convert between kilojoules and joules at the end. You'll be given some amount of mass in grams or kilograms or some number of moles, which you guys should know how to convert. You guys will be able to convert from mass to the number of moles. And to do this, you just do a simple unit conversion of the number of grams in 1 mole over the molecular weight in grams of whatever substance it is. This is just a skeleton equation. You guys can figure this out yourself. You can figure out the molecular mass or formula weight from the periodic table. The number of moles will be calculated, and then you know the number of moles, and you know a relationship between this is to get to just energy is in kilojoules per mole. So if we multiplied this number times this number, we'd be able to cancel moles and we'd be good to go. And we'll just be in a unit of energy. The other thing that you'll know is you'll know some kind of rate, because a rate is just a fancy way of giving you a conversion factor for unit analysis, which we've covered in detail in class in Chem 121 and Chem 122. So what you'll do is this will be given to you as some number of kilojoules or joules per second, and that can also be rewritten as well, it's not really equal to, but if you just flipped it over, it's 1 second over some number of kilojoules. So we can go from moles to kilojoules, and then we can go from kilojoules to time if we use this particular conversion factor in the right orientation. So all you do is after you've solved the formula for the energy units, you'll multiply the kilojoules by the conversion factor in the correct orientation, and that'll give you your amount of time, and you guys can convert that to minutes or whatever, or hours, or whatever it is that you need to do. That should have you guys good to go.